All right, this is number 42. It says a solution is made containing 20.8 grams of phenol. Right here, that's a ring structure that's got an OH coming off of it. In 425 grams of ethanol. Both have OHs on there, so they dissolve pretty well because they both have hydrogen bonding. Calculate the mole fraction of phenol, the mass percent of phenol, and the molality of phenol. So 3 different calculations we have to do, and I have the equations down for each one right here. Mole fraction, symbolized this giant letter X, is equal to the part moles, that is the solute, which is our phenol, divided by the whole, so the total number of moles inside of that substance. So the first step is to find the moles of each. And so we have 14.6 grams of the phenol. Oh, I'm sorry, I copied the wrong number down. 20.8, my bad. 20.8, I was looking at the wrong one. 20.8 grams of phenol. And phenol, when you put grams in a position where it's going to cancel, moles is a new set of units. And then when we add that up on the periodic table, there are 94.11 grams per 1 mole of phenol. Do that division and you end up with 0.221 moles of the phenol. And then read the correct question here. 425 grams of the ethyl alcohol, ETOH, right here. And when you add that one up on the periodic table, there are 46.1 approximately grams in a mole for that. Do the division there, and we have 9.23 moles of the alcohol. So now to find the part divided by the whole, we take the part, which is 0.221, and then divide it by the whole thing. So add 0.221 to 9.23. Don't multiply it by anything. Just take this number divided by this number, and it's a decimal number at the end, which after rounding for sig figs ends up being 0.0234. That is our mole fraction of phenol inside there. Letter B, the mass percent of phenol, so that's equal to the mass of the solute divided by the total mass, and we're given our mass right here, so that would be 20.8 grams, divided by the total mass, which is 20.8 plus 425. So part divided by the whole thing added together, and then times 100%. And when we take this and divide it by those two added together and then multiply it by 100, we end up with 4.67%. And then lastly, molality. Molality, remember, is equal to the moles of the solute divided by the kilograms of the solvent. And so our moles, we have what we calculated right up here, 0.221 moles. Divided by the kilograms, we have 425 grams, so 1, 2, 3 to the left is 0.425 kilograms just of the solvent now. And then when you divide those two, we end up using correct significant figures, 0.520 moles per kilogram, or the fancy way to write that is molal, a little script M like that. That's 42.